Ever get that feeling like, the universe is just this massive, like crazy place
Oh, absolutely.
with things happening so far away, so huge that it's almost impossible to even grasp. And yet we can kind of see it all.
It is pretty wild, isn't it? Like, we can actually observe events from billions of years ago, stuff that happened before our sun even existed.
It's mind-blowing right now. And that brings us to today's deep dive. We're talking about the collision of two supermassive black holes.
Oh, wow. Black holes are already mind-bending enough on their own.
Right. These things are regions of space-time where gravity is so intense that nothing, not even light, can escape.
Yeah, they're like cosmic vacuum cleaners, just sucking up everything that gets too close.
Exactly. And we're talking about two of them, each millions of times heavier than our own sun, smashing into each other.
I can't even imagine the kind of forces involved in something like that. It must be unbelievably violent.
Oh, it is, but it's also a delicate dance.
Hmm.
Before these two behemoths collide, they're locked in a sort of gravitational walls.
So they're like spiraling towards each other.
Exactly. As they get closer, their immense gravity pulls in all this surrounding matter, creating a swirling vortex of superheated gas and dust.
Like a cosmic whirlpool.
Exactly. It's a celestial ballet, but with very dramatic ending. Because as they draw closer and spin faster and faster, they warp space-time around them.
Space-time, that's the fabric of the universe itself, right? Like space and time all rolled into one.
Yep, that's the one. And when these black holes finally meet, it's not a gentle bump, it's, well, imagine the biggest explosion you could possibly conceive. Then multiply that by, I don't know, 1 billion.
So for a split second, this collision would be brighter than all the stars in the universe combined.
Brighter, more energetic, yeah. It's hard to even comprehend the scale of it. But the question is, how do we even know this is happening?
Yeah.
I mean, if even light can't escape a black hole, how can we observe it?
Yeah, that's a good point. It's not like we can just, point a telescope at it and see the fireworks.
Exactly. And that's where things get really fascinating. This cosmic clash generates something called gravitational waves.
Gravitational waves.
Picture this. You drop a pebble into a pond, see those ripples spreading outward. It's kind of like that, but in space-time itself. When massive objects like black holes collide, they create these ripples in the fabric of the universe.
So the universe itself is kind of ringing like a bell.
Yeah, it's like a cosmic echo of the event, spreading out across vast distances. But these waves, they're incredibly faint. It takes some really sensitive instruments to detect them.
Like listening to a whisper from across the galaxy.
More like a soundless scream, really.
Yeah.
One of the instruments we use to hear these whispers is called LIGO, the Laser Interferometer Gravitational Wave Observatory.
I've heard of that. It's like two massive L-shaped tunnels with lasers bouncing back and forth, right?
Exactly. Those lasers are super precise. And by measuring the tiny distortions in space-time caused by these passing gravitational waves, LIGO could actually detect these black hole collisions.
That's incredible. So it's like we've built this giant ear to listen to the whispers of the universe.
Exactly. And by studying these gravitational waves, we're not just witnessing a spectacular collision, we're gaining insights into some really fundamental stuff.
Like what?
Well, for example, the data from this black hole merger helps scientists refine their models of how galaxies actually evolve.
So black holes are important for more than just destroying things.
Oh yeah, definitely. See, supermassive black holes, like the ones we're talking about today, they're thought to reside at the center of most galaxies.
Yeah.
And they play a big role in influencing their growth and structure.
It's kind of poetic in a way. These forces of destruction are also forces of creation.
I like that. By observing these mergers, we're getting this glimpse into the processes that shape the universe as we know it, even our own Milky Way. And that's not all.
There's more.
Some scientists even think these black hole collisions could hold clues to the mystery of dark matter.
Oh, dark matter. That's the stuff we can't see but know is out there because of its gravitational effects, right?
Exactly. It makes up a significant portion of the universe, but it's invisible to us. Doesn't interact with light at all.
So how can black hole collisions help us understand something we can't even see?
Well, dark matter still has gravity. And by studying the gravitational waves from these mergers, we might be able to figure out how dark matter is distributed and how it behaves.
So, it's leaving its fingerprints on the gravitational waves.
That's a great way to put it. It's like we're using these black hole collisions as a tool to probe this invisible part of the universe.
That's amazing. So, by looking at these collisions billions of light years away, we're actually learning about the very fabric of our universe.
Exactly. It's like every time we detect a new gravitational wave, it's like opening a new chapter in the story of the cosmos. And it makes you wonder, what else is out there? What other mind-blowing events are happening right now that we haven't even begun to imagine?
Yeah, the universe is full of mysteries, isn't it? It's both humbling and exciting to think about all the things we still don't know.
Absolutely. And that's what makes this also fascinating. Every new discovery just opens up more questions and possibilities. And who knows what we'll find next. The universe is a pretty amazing place.
I can't wait to see what we uncover.
Me too.